So in this first problem, we're going to use the data given to find an exponential model that gives the amount of carbon dioxide Y in years. So our model is going to be Y equals Y sub 0 e to the k t. This Y sub 0 is my initial amount. So this is where my table starts. So I'm going to call 1990 t equals 0. So now I have Y equals 353 e to the k t power. That's still too many variables. I have 3 variables and we are used to 2 of them. So I'm going to solve for k by using the last thing in my table. So first of all, if 1990 is t equals 0, then we need to do 2,275 minus 1990 to find out whatever our t value is. And when you do that, you should get that t equals 285. So now I know my t value, and this is going to be the y value that I plug in with it. So I'm going to write down 2,000 equals 353 e to the k times 285 power. Now what I'm going to do from here is I'm going to solve for k so I can find out what my constant is. So to solve for k, the first thing to do is divide by 353. And so now I have 2,000 over 353 equals e to the 285k. This is in log form and it's not helping me, so I'm going to start at my base. I'm going to swooshy around the equal sign. So that gives me log base e, which we call ln, of 2,000 over 353 equals 285k. Then you divide both sides by 285. So in your calculator, you would type ln, open parenthesis, 2,000 over 353, close the parenthesis, and then you want to divide that by 285. And that will give you our k value. You should get that k is approximately 0.00609. Because k is positive, this is a growth, which makes sense because if you look at these values, they are going up as time passes. And now I can write my model. Y equals, my initial value was 353, e to the 0.00609 t. So there's my model. Now I'm going to use my model in the next problem to estimate the year when future levels of carbon dioxide will double in the pre-industrial level of 280. So first of all, this was the pre-industrial level, and I want it to double. So 2 times 280 means I'm going to have 560. So that's what I'm looking for as my y value. So I'm going to have 560 equals 353 e to the 0.00609 t power, and I'm solving for t. So divide both sides by 353. You're going to have 560 over 353 equals e to the 0.00609 t power. I'm going to swoosh. I'm going to get log base e, which is ln of 560 over 353 equals 0.00609 t. And then you have to divide both sides by this decimal. So if you type this in your calculator, remember to close that parenthesis. So you're going to do ln of 560 divided by 353, close the parenthesis, and then divide by the 0.00609. When you type that in your calculator, you should come out that t is approximately 57.8 years. Make sure you label your answer because it's in years. Next problem is money, interest. So remember we had those formulas before. A equals P-E-R-T. This was compound continuously. So this is how long will it take for money in an account that accrues a 3% interest rate compounded continuously, so we're going to use that formula I just wrote, to double. So when you read this problem, you probably only see one number, and that's okay. If you want to, you can make up an initial amount. So if I let my principal amount be 100, then my A has to be double that, which is 200. If you don't want to make up a number, we can simply do this. I'm going to let my principal be called P. So P, my principal, whatever that was, E, remember you have to change this decimal right here to this percent to a decimal, 0.03. And I'm solving for T because the question says what is the time. But it wants to know what is the time to double. So if I start with P, then I end with 2P, whatever the principal was. From there, you divide both sides by P. You get 2 equals E to the 0.03T. You're going to start at the base and make a swoosh like this. Oops. When you do that, you get log base E, which is ln of 2 equals 0.03T. Divide both sides by your 0.03. And so when you type this thing right here in my box into your calculator, you should get T is approximately 23.10 years. The next problem talks about radioactive substance, which you might have learned about in chemistry, and you're thinking half-life, which would be a great thing to think. Your textbook still uses the same formula from the previous page, which is fine. So it says that I start with 600 grams of radioactive substance, which are initially present, and 3 years later, there's only 300 grams. So my ending amount is 300. My initial amount is 600. E to the K, and it says T is 3 years. Oops. And divide both sides by that 600. In every other problem, I've left that fraction right there, but in this case, 300 over 600 is a half. It's very simple. So I'm going to write 1/2. The other ones I left exactly because they were nasty and long and would have repeating decimals. To the 3K. I'm going to convert. So when I convert, I get log base E, which is called ln of 1/2 equals 3K. Divide by 3. And you should get that K is approximately negative 0.231. That means this is going to be decay because the K value is negative. So my equation is Y equals 600 E to the negative 0.231 T power. And then it says how much substance will be left after 6 years. So you're going to use that model. And you're going to plug in a 6 for the T value. You type it in, and you should get that Y is approximately 150 grams. So you're going to use this process to complete your 4.6 homework.